going to see what is the syllabus contents completely related to digital signal processing architecture syllabus. Initially in the unit 1, the digital signal processing basics have been covered, and from unit 2, the real digital signal processing architecture details we are going to study. In unit 1, it is completely related to the introduction to digital signal processing. Nothing but first of all we are going to see what is a digital signal processing in the introductory part, which is introduction over here. In it we are going to discuss about different types of signals and what is a digital signal, what is the meaning of signal processing. Nothing but processing is nothing but doing some operations on the digital signal and how it is being carried out. And the second topic in unit 1 is sampling process. The sampling process is required to convert an analog signal to a digital signal. This is the basic important technique to be followed in the process of converting analog to digital. And what is discrete time signal, and what are the how we are going to represent the discrete time sequences. Nothing but x of n. X of n is nothing but it consists of some sequence of values in it, like signal sample, the sample values at different instances of time, discretized time. That values will be mentioned. We call that values as a sequence of numbers. Nothing but discrete time signal consists of a sequence of sample values in it at discretized time. The values at discrete times. What is discrete Fourier transform and fast Fourier transform also we are going to discuss. As we already know that discrete Fourier transform, which it converts the discrete time domain signal to a frequency domain signal, and it is of finite length, and it is suitable for finite length sequences only. And coming to fast Fourier transform, it is a simple algorithm which is applied to a discrete Fourier transform. It is not a new type of transform. Just fast Fourier transform is not at all a new type of transform. It is just an algorithm applied for DFT in order to reduce the number of computations, as the number of complex computations taken by DFT are more. Nothing but if we take multiplications, it is n square, and if we come to the additions n into n minus 1, that many multiplications is very difficult to perform, and it takes more time. To overcome that, we are coming up with a new approach of fast Fourier transform, and it is an algorithm applied for discrete Fourier transform to reduce the number of computations. And later on we are going to discuss about linear time invariant systems. What is linear system and what is time invariant system? Why it is called as linear time invariant system? Nothing but linear systems are the systems which are applied with the superposition principle. The systems which are applied with the superposition principle are called linear time systems, and the systems which are time invariant, nothing but the input and output relationships will be same throughout at any point of time. It does not vary with the time. It will be maintained constant. The input and output relations of the DSP system will be maintained constant at all the times. That's why we call it as time invariant. If a system satisfies both linearity and time invariance, we call it as linear time invariant system. Coming to digital filters, here we are going to discuss IIR and FIR filters. And in decimation and interpolation, these are general operations of DSP. We call DSP operations. What does the decimation do? It just decrease the sampling rate. What does interpolation do? It just increase the sampling rate. So why there is a requirement of decrease in sampling rate and increasing in sampling rate, all that we are going to discuss in this topic of unit 1. Coming to the second part of unit 1, here we are discussing about the number formats. Why the number formats are required in digital signal processing? In digital signal processor, signals are represented as numbers right from input through different stages of processing to the output. The filters also require number of specific coefficients, which are also represented in terms of numbers. So there are different or various ways of representing these numbers. Some of them are fixed point format, floating point format, block floating point format. These are the things which we are going to discuss in number formats in DSP systems. Coming to the dynamic range and precision of this number formats also we are going to discuss here. What is dynamic range? It is nothing but a ratio of maximum value to the minimum value that the signal can take. And what is a precision? It is nothing but it completely deals with the speed of DSP implementation. And we are going to discuss the sources of errors in DSP implementations. Some of the errors which are occurred at A to D converter while the processing is going on, and some of the errors in D to A conversion. So few errors I would like to mention here are quantization error and rounding off errors that majorly we will be discussing in this areas. And what is this compensating filter? There is a special type of filter which is used at the output of D2A converter to compensate the amplitude degradations which we generally observed at D2A output due to zero order holding. All these we are going to discuss at this compensating filter concept. This is all about unit 1. Coming to unit 2, here the major architectural features which we are going to discuss of these DSP devices. First of all, we are going to discuss basic architectural features such as the features which are related features with respect to the DSP operations like arithmetic operations, MAC, and simple MAC unit, ALU, and bus architecture and memory. All these, the operations such as signal scaling, logical operations, arithmetic operations, MAC operations, signal scaling, all these we are going to discuss here in basic architectural features. Coming to DSP computational building blocks, what are the major building blocks of DSP in computing or processing this digital signals? The major building blocks required are multiplier, shifter, MAC unit, ALU unit, bus architecture and memory. So these are the major building blocks which we are going to discuss in this topic. Coming to bus architecture and memory, here we are completely discussing regarding the Von Neumann architecture and Harvard architecture, and what is the difference between these two, and what are the types of memories we generally have, program memory and data memory. And if those were maintained in a single memory, we call it as Von Neumann. And when it is separated, when both the memories are separately used, then we call it as Harvard architecture. Coming to data addressing capabilities, generally the addressing capabilities of DSP which we are going to discuss here, nothing but immediate addressing, and there are some more addressing modes such as register addressing mode, direct addressing mode, indirect addressing modes. All these we are going to discuss in this data addressing capability. Coming to address generation unit, what does it completely deals with the basic functionality of this unit. What does it do? This unit provides addresses to the operands which are required for the general DSP operations like addition, multiplication. For example, for multiplication, if you want two operands, generally two operands are required for multiplication or addition. So what is the memory allocation or addressing allocation to each and every operand in that particular operations is being taken care by this address generation unit. Coming to some speed issues, here programmability and program execution completely here, branching, subroutine concepts will be discussed here. Coming to speed issues, in speed issues the parallelism and pipelining concepts were being discussed, in order to have the time, if the time consumption is more earlier, how to reduce the time consumption and how to increase the speed. That things which we are discussing in the speed issues like parallelism and pipelining concepts. And coming to features for external interfacing, what are the basic features used for to interface external devices? Nothing but direct memory access, which acts as a background to CPU, serial input output, parallel input output, all those things we are going to discuss here in features for external interfacing. Coming to unit 3, here we have a programmable digital signal processors. Nothing but the real digital signal processor, which is available in the market, and a very advantageous and very famous processor, TMS320C54XX DSP processor. Details we are going to discuss completely in this unit. This is an Texas instrument. They have been developed this instrument, and we in this unit the complete addressing modes, memory space, program control, and what are the interrupts and pipelining operations done on this particular TMS320C54XX DSP processor. We complete details we have been discussing in unit 3. Coming to unit 4, the as a name itself suggests that we are completely discussing regarding analog devices families of DSP, and these are some of the names which is being mentioned here. All these shift instructions, block diagrams of all these ADSP devices we are going to discuss, and we are discussing about hardware processing units, register files, control unit, bus architecture, and all those of Blackfin processor. And coming to unit 5, in previous units we are going to study about the architecture of DSP and we are going to learn about instruction set and programming techniques. But in complex DSP system, in addition to the processor, there are some external peripherals interface to processor either in serial or parallel mode. So here the parallel IO which is being mentioned here, this parallel IO interface, this completely deals with the ports that are used for interfacing with external devices such as A to D or D to A converters. Coming to programmed IO, there is a topic called programmed IO also here, that it completely gives us the details, like here when the CPU keeps polling the external device until it is ready for transmitting or receiving data, it keeps on polling the external devices. That concept which we are going to discuss in programmed IO. Coming to interrupts, you might be already knowing this while you have studied microprocessors and microcontrollers. There are maskable and non-maskable interrupts. The same over here, we have IO interrupts as well as maskable, non-maskable interrupts that we are going to discuss here in this concept. Coming to the last topic, direct memory access. As I said, it is a background, it acts as a background to CPU, nothing but it transfers the data between regions in the memory space, or else simply we can say that it is between memory and peripheral without any intervention of CPU. That is being taken care by this DMA. And the best books to be followed for the syllabus is, you can see the major 90% of the syllabus is being covered in Avtar Singh and S. Srinivasan, which is Thomson Publications in 2004. And you can go with this practical approach to digital signal processing by K. Padmanabhan, and somewhat references you can go with embedded signal processing with the micro signal architecture publisher. This is the complete syllabus related to digital signal processing architecture. Let us discuss each and every topic one by one in the coming sessions. Thank you. Have a nice day. And I would like to mention here is, please follow the later on videos for the complete topics which we are going to discuss in the coming sessions. And I would like to mention another important thing is, the subject is very easy to understand. Just you need to go through the architectural features of each and every block which is there in digital signal processing. There is no much complexity in understanding the subject. Everything will be fine. Thank you one and all.